have a hard time recognizing. So if I bring another one over, I'd have to have enough negatives to balance that one out. So every one I bring over is going to have this ratio. It's going to be 1 to 3. All right? So let's say that this, what charge could this be off of your chart? Give me a one in the +3 column I could use. On this chart I just gave you, the cation and anion chart. Find a +3. Tell me which one you want to use.
Iron.
Okay, iron. Okay, so iron 3. That tells you its charge. So we're going to take iron, we're going to put it down here. Fe is the plus. Okay, find one over in the -1 column. I don't care what it is.
Fluoride.
Fluoride. Okay, fluoride is the way you would name it if it has a -1 charge. We name fluorine if it's neutral, but we name it fluoride to differentiate between neutral and an ion. So fluoride's the ion. Okay, and it has a -1 charge. Okay, so if I had to write the formula for this, what would the formula be when they get together? Fe, what? F, and is that it?
Of course not.
Of course not. What is it? Fe, F. I'm going to put a 3 indicating how many of those -1s I had to use to balance out the +3. I have to use 3 of them to balance out the +3. Okay? Questions on that? So that's all we're doing. I think we... Go ahead.
Next to fluoride, the symbol F has a little negative sign on it.
That means it...
Use that in the equation.
when you're done with the formula, you won't show negatives or positives.
Okay.
And the reason why is because they're gone, because now they're balanced out. Right? And I'm going to have to use this tomorrow with them because they were struggling. Anytime I get them to where we're using the formulas in that, we'll do 2 more like this, and then it becomes a lot easier when we have to do an activity. Okay. So I'm going to go ahead and we'll do another one here. We'll make this over here. We won't do as many. Okay, so let's do this. Let's have one float over here, +2, and let's see what we can do to balance these out. So let's just do it, and then let's see what we can do to balance it out. So we got +2. We bring over a -3. Is it neutral?
No, then you...
It's a -1.
+2.
Right, so if it's a -1, we've got to bring another one over. That's a +2. So we bring that over, +2. Is it neutral?
Nope. Then you put a -3.
So then we bring over our -3. How about now?
Yes.
No.
What?
-6 and +4.
One more time, Paul.
Oh, wait, I was doing stuff.
Is that neutral? This is the toughest one you'd have to do. You have to make sure they all, when you put them together, form a neutral particle. Now it's neutral. I've got 2 -3s and 3 + 2. So I think the other day I was saying if I add 1/2 plus 1/3, I got to get both of those to 6, right? If I add those up, you need a common denominator to match up to where if you're adding them together, it has to be 3/6 plus 2/6. Gives me 5/6, right? What I've done is I made the denominator common. Guess what I have to do with charges? I have to make them common. I have to make them the same. So if I got a 2 and a 3, guess what the total charge of positives always have to be?
0.
Well, when you combine them, it'll be 0. But if I have a plus 2 minus 3 or plus 3 minus 2 combination, we're going to have to get those charges to what every single time? 6. Got to get them to 6 every single time. So if that means we have to have 3 plus 2s and 2 minus 3s, that would be our formula. So give me a plus 2 off your chart.
Mercury.
Hg plus 2. What's a minus 3 off your chart?
Phosphate.
Okay, now phosphate, this is a kind of a tough one because it's a polyatomic ion. And a polyatomic ion is more than one atom hooked together. And so we haven't dealt with those, but it shouldn't be that difficult. The 4 never can change, and it always has to be written this way if you're going to write it out in the formula. So we're going to take the Hg, bring it down. How many do we have of Hg?
Blue. Blue. Not so much.
So how much do we have of Hg? How many? 3. Then we're going to put the PO4 here. Okay, how many do we have of those? 2. Now, if we have 2 of those, you always have to treat polyatomic ions this way. If I put a 2 here, what would that look like?
42.
42 oxygens. I can't do that. Okay, what would be what you do in math to separate when you have numbers that you're using and which you want to show that separation? What are you going to have to use?
Parentheses.
Parentheses, right? So if I put this in parentheses, see how that separates? And now I have 2 of those phosphates. This represents a phosphate. I have 2 of them.
Cool.
So this charge is plus 6. This charge is minus 6. Okay?
Okay, so
Go ahead.
phosphate has what in it? 1 lead.
1 phosphorus, 4 oxygens.
Okay.
And that when that goes together, it makes an overall negative 3 charge. Okay? Alright, so let's get to, hopefully this transition will make this easy to do. I don't know, it's something I'm trying, we'll see. So we're going to do the first one. The first one says we have sodium iodide. So here we have sodium iodide. So do this in your notes section and just have these labeled like this. I'll wait for you to do that. So go ahead and write sodium iodide name, and then the next column is cation, anion, and formula. So go ahead and do that in your notes. This one's going to be cations what of these 2? Which one of these 2 is our cation? Be the ones up above. So which one of these 2 is our cation?
Sodium.
Sodium. Okay. And then, of course, the other one has to be the anion, and so I messed up there. I'm just going to go ahead and write the formula, the symbol for sodium. That's what I need to do. So what I need to do is write Na plus 1. It's in the plus column, it's plus 1. I like writing plus 1. The anion's iodine, and it's minus 1. What is the formula for sodium iodide? NaI. Do I need any subscripts changing how many I have of each one? No. They're equal. You like those that are equal and they're the same and opposite charge, because then all you have to do is write one of each and you don't have to worry about it. Okay? The next one, it gives us copper 2 chloride. Now, I'm going to explain why they have to say copper 2. So the next one's copper 2 chloride. Okay, the 2, copper can be a 1 or a 2, because it can be in the 1 column and it can be in the 2 column based upon losing different number of electrons. Copper 2 loses 2 electrons, so it's copper 2. So I'm going to write Cu, and then what charge am I going to write up above?
Plus 2.
Plus 2. And chloride, I look at that, find it on the chart, and chloride is what? Should be the anions.
Minus 1.
Minus 1. Okay? Now, I want to put these together so that the charges are equal. So I'm going to put, how many am I going to have of each?
You're gonna have to have one copper and, one copper and 2 chlorides.
Okay, so 1 copper is plus 2. It's kind of like my particle that was plus 2, and then I had the plus 2 here. And then I had these chlorines that were minus 1 floating around. I need to have 2 of those come in and hook on, and that gives me my formula. Cu, Cl, 2. Because it takes 2 of them. Okay, that's the way you need to do it. Now, if you need to draw them out like that, I encourage you to do that. I mean, if that's something visually you can see a lot better than that up above, it might help you. Okay, it doesn't take long to do. All right. Third one, baking soda is sodium hydrogen carbonate. So third one, sodium hydrogen carbonate. Okay, I'm going to let you guys write in the cation and anion. So find those. Hydrogen carbonate is also known as bicarbonate. So write those 2 in, and then write your formula. See what you think it is. Is that what you guys got? Okay. All right. I'm going to do one more, and I'm going to do number 5. Yeah, we'll do 4 and 5. They're a little different. So, number 4 is the first one you have where you're given a formula. They give you the formula. You don't have to do anything with that. That's really easy to do, because then all you have to do is look up the SO4. It's a minus 2. You look up the calcium. It's a plus 2. So then my formula, or my name, I look up Ca, it's calcium. I look up SO4, it's sulfate. Now be careful, because there's SO4 and SO3. SO4 is sulfate, SO3 is sulfite. Okay. The next one would be the toughest one you'd have to do. If you had to do one, the next one would be the toughest you'd have to do. So that one tells you the ions. Ca plus 2, PO4 minus 3. Go ahead and write down what you think the name is and the formula is based upon those charges. So you go ahead and write the formula, and you write the name. So the name's real easy, right? The name is calcium phosphate. This is a little trickier over here. 2 and a 3. If you do enough of these, they become automatic. So I'm going to put a Ca and I'm going to put PO4 side by side. And how many Cas do I need? How many? 3. Why do I need 3? What do I need to get the charge of this to? 6. So I need 3 of those. And then this is a minus 3. I need to get that also to 6. So that would be 2. Now, again, we don't put a 2 down here like that, because it looks like 42. So we want to put a separation like that, and now that's the formula for calcium phosphate. If I go in the back and I look at calcium phosphate and I get a container that's got a solid in it, that's the formula that will be on there. It tells me you need 2 of this for every 3 of that, and that's your kind of your equation for that particular example. I won't have you do 6 through 10. I'm going to pick out 3 to do. I want you to do number 7, number 8, and number 9. 7, 8, and 9. Just do 7, 8, and 9. So on your chart, you have aluminum, and on that chart, aluminum is a +3. So Al +3. And sulfate is SO4 on your chart, and it's a -2. So, again, I can do a drawing down here. +3. Another particle is a +3. +3. And then over here I have -2, -2, -2, -2. So then we have to make a decision how many we need of each to get a neutral compound. Okay, if I take 2 of these and make it +6, how many of these do I need? I need 3. Now they are equal. Charge opposite. +3 or +6 -6. So that formula should be Al. We have 2 of the +3 right here. And we have 3 of the SO4s. And they're right here. The SO4s are here. And these are the aluminum. So see, they match up. 2 to 3. Barium, magnesium hydroxide, magnesium's a +2, hydroxide's a -1. So, on that one, the -1, we need 2 -1s to equal the +2. So it's MgOH2. And then the calcium carbonate, that one's really easy because they're both the same charge. Both the same charge, you write them side by side, and that's your formula for those. Okay? So, need to do 1 through 10 on the extra practice worksheet, and get that done for tomorrow so we can check your answers.